Hi, third grade. So this morning we are focusing on Unit 10, Lesson 7, and we are going to be working with real life problems with area. But before we get to that, I want to go over the distributive property with you. So I'm going to do one example, and then for the problem of the day, you are going to solve this problem on your own and post it to Seesaw. So let me go through this carefully because the other day when we were doing these, a lot of us weren't sure what to do. So let's go over these steps. So remember, the distributive property, we're going to take a number. It doesn't matter which factor you take when you're multiplying. You're going to take that number and you're going to break it up into two addends that add together to equal that number. So for this problem, I chose 7. So I'm going to take my 7 and I'm going to think, what two numbers add together to equal 7? It doesn't matter which numbers you choose. You can choose a different number than someone else as long as it equals 7, the sum 7. So I'm going to go ahead and pick 5 and 2. 5 plus 2 is 7. Okay? So basically, all you're doing is taking the 7, you're breaking it apart, and then we're going to distribute it or share it and pass it out. Watch if I draw an array really quick. 1, 2, 3, 4, 5, 6. It's 7 groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And last one. So I have 7 rows of 6. What I'm basically doing here is breaking up that 7 into 5 rows of 6 and 2 rows of 6. 1, 2, 3, 4, 5 rows of 6. 1, 2, 3, 4, 5 rows of 6 and 2 rows of 6. That's all I'm doing. So should your answer to this be the same? Yes. Okay. So let's look at this. So now what we're going to do is start distributing. My 6 always stays the same. So in parentheses, I'm going to put 5 times 6, and I'm going to check off that I used the 5, plus 2 times 6. Okay, I'm keeping my 6, and I'm distributing the 5 and the 2. Now I have 5 rows of 6 and I have 2 rows of 6. And I know that whatever that is added together is going to equal how many I have in all in my array. Okay, it's going to equal my product. So 5 times 6 is 30. 6, 12, 18, 24, 30. Plus 2 times 6, or 2 rows of 6, is 12. 6, 12. And I know that 30 plus 12 is 42. I have 30 here, I have 12 here, and those added together is equal to 42. And I know that 7 times 6 is also equal to 42. All I did was take my 7, I broke it up into 2 addends so that I can have kind of a new problem to solve, okay? So what I want you to do now is go back to this if you need to look at it one more time, and then this is the problem that you're working on. So use the distributive property to solve and post your work on Seesaw. So 8 times 9, and I told you that you're going to be breaking up the 9. So I need 2 numbers that add together, 2 addends that equal 9. And then you're going to, what stays? Okay, that'll go here. And then I want you to input in your 2 new addends and solve, okay? So write this down, pause it if you need to before we move on, and then you're going to post this to Seesaw. So write this down in your book so you're ready to go. All right, so on to the objective. Today I will apply my understanding of area to a real life problem. So we're going to look together at your math task. So this is actually the math task that's in your book that you're normally going to do, but I'm going to do this as an example for you, and then you're going to do the homework as your work today, okay? So let's read this together. Edward needs to paint a treehouse, okay? There are 4 walls in his treehouse that each measure 8 feet long by 9 feet high. And there are 4 of those walls. So I'm gonna draw that. 4 walls in his treehouse they're all the same. They're 8 feet long by 9 feet high. Okay, so 8 feet long and 9 feet high. So far, before I even keep going, I should know that I'm finding the area because it's telling me about the entire surface of the wall. Let's see what he wants to do with the walls. Each gallon of paint covers 200 square feet. Can Edward paint the room with 1 gallon of paint? Create models to support your thinking. So we know that 1 gallon of paint covers 200 square feet. So we need to figure out, well, how many square feet is each wall? Okay, how many square feet is each wall? And then we have to figure out how many gallons of paint does he actually need. So let's see what we're gonna do. We know that our formula for area is area equals length times width. Okay, so I'm gonna look at I know that I have 9 by 8. So my area, I just know that I can multiply. So I'm gonna do 9 times 8. And I know that 9 times 8 is 72 square feet. So one wall, because remember, this only applies to one wall, and he has 4 walls. So one wall is 72 square feet. Now, are all my walls the same? Yes. So I know that every single wall is 72 square feet. And how did I find that? I know that the wall is 9 by 8, 9 feet high by 8 feet long, and to find my area, I'm going to multiply the length and the width, or that how high it is by how long it is, and 9 times 8, 72. He only has 200 square feet, or he has a gallon of paint that covers 200 square feet of wall space. So we need to add all 4 of our walls together to see if this is going to be enough paint. So 72 times 4, but we're just going to go ahead and do 72 plus 72 plus 72 plus 72, which is equal to 2, 4, 6, 8, 7, 14, 21, 28. So he has 218 square feet of wall space that he needs to paint. Well, my gallon is only 200 square feet. What's wrong here? He needs 18 more square feet. Right? So is this going to work? Is this going to cover all of his wall space? No, it would cover almost all of it. You're super close, but that would be really sad to be almost done with your work and then, that's why we do our math ahead of time. Okay? So we know that he can't use just 1 gallon. He's going to need 2 gallons of paint. Okay? And why does he need 2 gallons of paint? So let's write Edward needs 2 gallons of paint because all 4 walls are 218 square feet, and 1 gallon only covers 200 square feet. Okay? So your work for today, actually, let me get this for you. This one shows the homework. So on your homework today, it says, Annie has enough paint to cover 100 square feet. She decides to paint 3 walls of her walk-in closet. Each wall, so there's 3 walls, and each wall is 6 feet long by 7 feet high. Does she have enough paint? Create a model to support your thinking and then explain your reasoning. So is 100 square feet of paint enough to cover her 3 walls? So this is what you're working on today. And then I'm going to have you, it's in the instructions on your daily assignments, but I need you to post the distributed property problem of the day to Seesaw, and then I want you to post this to Seesaw to make sure that we're on the same page. Feel free to video chat me if you need help with this, because I know this can be a little bit tricky, okay? So thank you for listening, and go ahead and get started.